This video is brought to you by makeITsimpleTT, the premier online learning space for CSEC IT and computer science classes in the Caribbean. All our classes are run on the familiar and secure Google Classroom platform. The weekly videos are well laid out and labeled by topic, dated, and placed in reverse chronological order to ensure easy access even if you miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. So what we're doing tonight is we continuing from the last video, which was the last video I taught you all the way up to loops, and you learned about for loops, repeat until loops, and while loops, right? Those are the three major loops that you will learn. For loops is definite, repeat until, and while loop, those are indefinite because you don't know when they stop. Now that we have all this power and we're able to use sequential, selection, and loops all in one, now we're able to start to apply some techniques. Now these techniques, they are like how you would manipulate the ability to speak to the computer. Now that we know how to speak to the computer and we know how to use sequential control structures, selection control structures, and looping control structures, we now could put those things together and make like a way to manipulate the computer. It's kind of like English. So like you learn the alphabet and you know A, B, C, D, E, F, G, and you know numbers and whatnot. But when you start to put the words together, you're able to form sentences, and when you're able to form sentences, you're able to form paragraphs, and you're able to form paragraphs, you could form stories. And if you could form stories, then you could form, make chapters. If you can make chapters, then you can make a novel. And that's basically how programming goes. You could start off learning the basics, and now we're going to start to apply what we know into something that is tangible. So let's start with our counter, right? Our counter. One of the most important things that we should be able to do when you're programming is how to keep track of something or how to count up something. I'll explain to you why when we go to some of the examples, but you will see. So, counters are used within indefinite loops, example while and repeat until, to determine when the loop should exit. So a counter could simulate a for loop if you wanted to, but we'll get to that just now. But I'm just going to show you how a count works. So you count up by using this equation or this statement. Count is equal to count plus 1. So here's what happens. If I have a box called count, and I tell the computer count is equal to count plus 1, what that really means is if I have 3 inside count, 3 plus 1 is going to update and count is going to change to 4. But what your computer really doing is it doing something like this. It'll be like the box here has count in it. Count has a 3 in it. So it will take the 3 out and say 3 is equal to 3 plus 1. Well, 3 plus 1 is equal to 4. So therefore take that 4 and put it inside by the count and it will update to 4. That is what this statement does. So it gives us the ability to manipulate a computer to keep track of a number for us. And once you can keep track of a number, you can do many things because you now have the possibility or the capability to do so much more than you used to do before. So count is equal to 0 is how we would start off. You have to declare it and set it on what was the same way? Hold on, pause for a second. Something going on in chat here I need to know. My first time here and Fate was trying to. I'm not doing IT, I'm just chilling. I ain't cleaning them yet. I went inside the DM and he sent it for me, I still waiting. When I say so, please come for Christmas. Can you do web developing? What was I saying? Yeah. Yeah, next year I'm going to offer a web development course for students who on like vacation. So July, August I'm going to offer a web development course. And people who want to learn HTML, CSS and JavaScript. And I might also do our next Android app development course. But it really depends on how fast CXC push back exams this year, because if we go normal and you actually get a full July, August, we could do plenty. But depends on how things goes. But anyhow, let me get back to the work because all you have me talking in the chat here, and I just imagine the people who really came to learn. They like sitting down here like, I come here to learn algorithms and
I have to stay here. What is this? No, tell me what is this? I want to know what is this. This is madness.
So to the people that want to learn algorithms, right? So as I was saying, right, what I was saying was, count is equal to 0, right? If I set the count to 0, I am telling the computer, okay, set this thing here called count, which is this box right here, and I'm setting it to 0 at the start. When you set it to 0, what you're saying is you're going to now create a scenario where the value of count is going to change. So I asked the computer, while count is less than 30. So as it stands right now, 0 is less than 30. Yes, it is. Good. So because this is true and the answer to this is yes, it is true, then go ahead and do some sort of statement that I put inside here. The statement that I put inside here is going to keep going over and over and over because it's a while loop. If you're struggling to understand how this while loop is working, there's a video from last week. BT dubs, right? But if you're not struggling, then you'll just be like, okay, cool, I understand. While count is less than 30, count is equal to count plus 1. So what this really means is carry up the count by 1. So count is currently 0, so 0 plus 1 will become 1. So now count is 1. Yay! Happy, happy, joy, joy. So we go again. We loop one more time. Count is count less than 30? Yes, right now count is 1 because we just added 1 to count. So now the whole process will go again and count will be count plus 1. So it'll be 1 plus 1, which will change now count to 2. And then count will change to 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and all the way up. And then eventually count is going to reach 29. Right? So when count reaches 29, it'll be like, okay, is 29 less than 30? The answer is yes, it is. So the next thing that will happen is 29 plus 1 will give me 30. So count is going to change to 30. Now the while loop's job is to check to see, okay, what is the value of count now? And once this thing reaches 30, it'll be like, is 30 less than 30? The answer is no. And once it says no, then the while loop will stop, and then it'll just display the count, and the count will be 30. And that proves that you got it to go 30 times. But the real key is I was able to keep track of how many times the loop ran to get it to go 30 times. That's what I say in there, right? So as the first major technique you need to know when you're doing loops, how to count. Because if you could count how much time the loop runs, you'll be able to do things like calculate average and that kind of stuff. Terrell, what do you mean, what about indefinite loops? I don't understand what you're saying. Infinite loops? I went through infinite loops last week. Right. So now, look at this. Let's see how we could find the total of a set of numbers. So if I told you, get the sum of 10 numbers, you could, if you are so inclined, be like, get A, get B, get C, get D, get E, get F, and all the way down to how much 10 letters is. And then it could be like sum is equal to A plus B plus C plus, but that's not very practical, right? That's the whole point of learning loops. Loops gives you the ability to repeat those monotonous things, which is why we have computers in the first place. And now we could take that repetition and apply it to something. So watch this. This is kind of cool. Let's say I want to find the sum of 30 numbers. I start off by setting count is equal to 0, and then I read a number. The reason I read a number is because I can, right? Because I have to get the number from the person. So the person puts in the number as, I don't know, 5. 5 is the first number, right? So we read 5. Says count is less than 30. So we know count is less than 30 because, well, we want to do it 30 times. We just learned how to do a count. So we're applying it to our actual question now. So this statement here, you see sum is equal to sum plus num, is the same concept as the count. Trust me, for your whole programming life, you're going to learn how to use this. To keep track of a running total is basic, fundamental. The kind of stuff that you sit down and just do and be like, whoa, I know how to find a running total. And you'd be like,
sometimes my genius is, it's almost frightening.
trust me. When you could get a running total and then get the average, you think you're very smart. And, well, you may or may not be, but feel good, you can feel good, right? So if I say sum is equal to sum plus num, watch it. Sum is a box. Num is a box. In this case, I'm assuming that the person puts in a 5 for num. So if you put in 5 for num, that means they're going to take this 5 and add it to what's inside sum. What is inside sum now? Nothing. So 5 plus 0 will give me 5. So the running total is 5. So let's say the person puts in a 5. Cool. So how it does that is, it reads the number here, and let's say, assume we get 5. Now we'll take 5 plus 0, and the result of 5 plus 0 will go inside sum, and sum will change to 5. Then count goes up by 1. Why is count going up by 1? Because we want this to run 30 times. Because I want it to run 30 times, I have to keep track of the count, because keeping track of the count gives me the ability to control the loop, to know when the loop is going to finish. So I read a new number. Let's assume Phil puts in a 6, right? Phil is the name of the person putting the number because I say so, right? We go back up, end while. The end while will check now, what is the value of count? Well, count just went up only by 1, so right now count is 1. Is 1 less than 30? Yes. Great. That means now we could get the new number. The new number that we're going to get is a 6. The previous value of sum was 5. The statement says sum is equal to sum plus num. So I'm going to take the 6 and add it to the 5. And now sum is going to update to 6 plus 5, which is 11. And now that I have the 11, sum has gone up to 11. Did I find the sum of the two numbers so far? Yes. 6 plus 5, 11. And then the count will go up again. So count goes up to 2. Is 2 less than 30? Yes. So you can imagine that this loop will keep going. And it will go. And it will keep going. And it will keep going. And keep going. And keep going. And eventually, whoever is using the program would have put in 5, 6, 1, 3, 2, all the way down to whatever other number they decided to put, which will be like a 4 or something. And at the end of it all, this statement here, sum is equal to sum plus num, will keep adding all the new numbers back to the previous value of sum, and it will keep updating constantly as long as the loop is working, or as long as the loop is available. The only time this loop will stop will be when the count reaches to 30. So this, calculating the total, is one of the greatest techniques that you need to learn when you're using a loop, because it keeps track of how many times something happens. You'll see this in your SBA, you'll see this in questions, you'll see this in programs, because keeping track of the amount of totals is always necessary. So like for the sample SBA, they'll ask you to keep track of how many people voted. Well, you have to put in a total, which will be like sum is equal to sum plus num, or A is equal to B plus A, or some kind of thing like that. Right. So that's two techniques that you need to know in loops. Here's the next one. There are two types of loops. There are definite loops and there are indefinite loops. A definite loop means it goes from a particular starting point to a particular ending point, and you know how it works. An indefinite loop, you don't know when it's going to stop. But with a counter, you could make an indefinite loop act as if it is definite by controlling how much time it counts. And this is really cool, because all of these things I'm showing you here, these are powerful ways that you actually use loops in real programs to get things done. So let's see how that works. What we're going to do is look at our for loop. So look at the for loop, start to the right hand side, right? Look at this for loop. This for loop says for count is 1 to 5. So how much times is this loop going to run for? 5 times. And I know it's going to run 5 times. I'm sure it's going to run 5 times because it says go from 1 to 5. And the things that we want to do is we want to calculate the sum of all the numbers. So we're finding our running total, and we'll just keep adding up the total of 5 numbers, right? How do we do that in a while loop? Well, for a while loop, I have 3 things that I have to set. If you want a while loop to act as a for loop, you have to do 3 things. This video is brought to you by makeITsimpleTT. Our CAPE classes run on an 8-month cycle and covers everything in the CAPE IT and Computer Science syllabus with 10 years of past paper practice included. Students get assignments topically and reports are emailed to parents and guardians monthly or bi-monthly. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. You have to 1. Set the start value. So first one, set the start value. The start value is 0. Why am I starting it at 0? Because I have now a condition to check. So the second thing you have to check is the condition. So you start off at 0. You want to go to less than 5, that means it's going to go to 4. So you'll be going from 0, 1, 2, 3, 4, which is 5 times, because 0 is a number, right? And then the third thing that you need to do is you need to increment the count or carry up the count by 1. When you carry up that count by 1, you now have all that you need to control the start and the finish of a loop. Same thing this for loop does. The for loop sets a variable to start, gives you a starting point and gives you an ending point, and it basically tells you go up by 1. Kind of cool that a for loop and a while loop could do the exact same thing. It's just that the while loop you could control the 3 things that are necessary. Everything else you'll realize is the same. This here is the same as that there. The display sum is the same as the display sum there. Set any variable, read num, setting sum is equal to 0. All those are the same things. But the things that differ would be, in a while loop, you have to control how this while loop is going to actually go. Yeah. Right. Now, once you understand that you could simulate a while loop with a for loop could simulate a while loop. Now, any loop that you use could get the job done. There are some loops where you need to get the user to input when to stop. Well, then you have to use an indefinite, which will be like a while loop or repeat until. But there are some loops where you could tell how far you want to go, and you could use a for loop if you want, or you could use a while loop if you feel like it. One or the two, but both of them will still work. For loops are usually the most common ones because for loops are easy. So let's look at a next way that you could make a loop work for you. Maximum. So let's say we wanted to find the highest of a set of values. The reason you want to find the highest of a set of values is because, sorry, I drank some soft drink just now and that didn't work out too well. I should be apologizing. Whoa.
1 hour later.
Yeah, that yawn was a little tough there. I am, apparently, I'm tired. So, yes, so we're back to this maximum, right? Maximum, right. So, if you want to find the largest of a set of values. Now, if I tell you, hey, I'm giving you a set of numbers. 2. What's the largest number so far? Well, the largest number so far is 2, because 2 is all you have. And then I give you a next number. 3. What's the largest number so far? Well, in your brain, you instinctively already compared 3 to 2. The 3 to the largest number that I have so far. And you're like, hey, 3 is bigger than 2. So therefore, the largest number is now 3. Okay, cool. No problem. Then you give a next number, and the next number you give is 75. In your brain, you're like, okay, is 75 greater than the highest number that I have so far? Yes. So therefore, the highest number changes to 75. What went on there? Okay, Google Assistant. I didn't ask you for help, but I appreciate it anyhow. And then you get the number 4. What you're going to do is you're going to check to see, hey, is the 4 greater than 75? No. Therefore, we will not update it. And that is literally how maximum works. How do we get the computer to do that? Well, here's how you're going to get the computer to do it. For the computer to figure out what is maximum or minimum, you have to first set a maximum value. The reason you're setting the maximum value as 0 is because the first number that you get will automatically be bigger than 0. Well, hopefully you're not dealing with negative numbers. If you're dealing with negative numbers, well, but that's above your pay grade right now, right? You set the maximum value to 0. When you set the maximum value to 0, you are telling the computer, okay, max is currently 0. So when you have to do your first comparison, compare that number to 0. So let's assume Phil puts in a 3. What will happen now is we will read the number we're getting is 3. Is 3 not equal to 0? The answer is yes. So because the answer is yes, now I get to do all of this inside here. Now all of this is inside here because this is the logic that you're going to use to calculate the max. So here's the logic. If the number I just got, which is a 3, is greater than the current maximum, which is at this point in time is 0, it never changed. So the current max is 0. Then take that number and put it inside max. So there is a little box for max here, and there's a little box for num. Right now max is 0, number is 3. Is 3 greater than 0? Yes. Take the number that's inside num and put it inside max. And that's now going to change the max to max. Yeah, it's going to change the max to 3. So now max is 3, and this little if statement here will end. This here is the real power because this makes the choice of if it's bigger or smaller. Then we read the number again. So we read a new number, and let's say assume that Phil puts in a 4. So Phil puts in a 4, and then we have to say, okay, is 4 not equal to 0? The answer is yes, 4 is not equal to 0. But now our decision is a little different because our decision is saying if the number that you just got, which is a 4, is greater than the current max. What is in max so far? Inside max is the number 3. So now our question is 4 greater than 3? The answer is yes. So therefore we do this swap thing here. Num goes inside max. So we take the 4, put the 4 inside here, and now max changes to 4. Like, wow, that's amazing. It's like,
Oh my god! Wow!
it's amazing. So this process will keep going on as long as Phil, homeboy, doesn't put in a 0. Now Phil could put in a 2, a 1, and a 3 here. 4 will still be the highest number that we ever got. As soon as Phil put in a 0, we'll read the number and we'll get a 0. And it will say, while 0 is not equal to 0. Wait, the answer to that is not yes. The answer to that is no. Because the answer is no, we stop everything that's inside the loop. The whole while loop is done, and then we'll just print out the max. And what you'll realize is that the maximum value, which is 4, will have risen to the top because we'd have compared it to every other number. And when you compare it to every other number, you'll find the maximum. And I just saying, this is wonderful. This is nice. So let's see now how we could find the minimum. Well, look at this. Let's say we want to find the minimum. The minimum is going to be found by you first having to set the minimum value as 9999. Why do you set the minimum value as 9999? Well, because you're finding the minimum, what you want to check for is you want to check to see if the biggest possible number that you could put in will always be higher than the first number that you get. So if I put in a number and they ask me for, okay, this algorithm is to find a set of minimum numbers, and the first number I put in is 122. What is the smallest number so far? The smallest number is the only number that I have, which is 122. So 122 is currently the smallest in my head because I've compared it to infinity. But in a computer's mind, you can't do that. So that's why you have to set the minimum value to 999 at the start, and that tells the computer, hey, you have a starting value for what small is. And now, any other number that you get should be smaller than that, so that will fix the case of your first number being the minimum. So watch us now read number, what number I said we got? 992, okay, so I'll set up a min This is exactly how the computer will set up the memory. Not exactly, but you know what I mean. That's how the computer views it. So the minimum value at the start is 99999. Nice, good. So while the number is less than 99999, is the number less than 9? It's 122. Is it less than 99999? Yes, it is. Guess what? If the answer is yes, then you actually get to start the loop, because the while loop is dependent on the condition being true. That's just how things work, right? If number is less than minimum, which is number is 122, is 122 less than 99999? The answer to that is yes. And if it's yes, then you want to take the number and throw it inside the minimum. So 122 is going to now 122 is now going to update and go inside the 9999, and then you'll get 122 becoming the smallest number so far. So we found the minimum. Yay! But what if Phil puts in another number like 10? What will happen? Well, let's assume Phil puts in a 10 down here where we read the new number. The while loop will go back up and be like, okay, what just happened? We got a new number of 10. Is 10 less than 99999? The answer is yes, it is. So because 10 is less than those numbers, now you're going to check the new number, which is 10. Is 10 less than the current minimum? What is the current minimum? 122. So if 10 is less than 122, then our instruction is swap them. Take the number and put it inside. Not swap them. Take the number and put it inside min. So the new number that we just got was 10. Take that 10, put it inside by the 122. And the answer is now minimum becomes 10. Notice the lower number always gets put inside the minimum value, because if it's smaller, you will change them. And then Phil could keep putting in numbers from now till whenever. 16, 22, 90, and then like 99999. Plenty nines, right? Basically a number that's bigger than it, which will be like 100,000. I like 100,000. Phil goes in and puts in 100,000 at the end. What happens is it will keep going through the loop over and over and over and over and over. Every single time it's going to compare this new number to the smallest number that it got the last time. Is 16 less than 10? Nope, the lowest is still 10. Is 22 less than 10? Nope, it's still less. 10 is still the minimum. Is 90 less than 10? Nope, it's still less than the minimum. 100,000. What the 100,000 is going to do now is if we get 100,000 here, it'll be like, while 100,000 is less than 9999. But the answer now is no. Because the answer is now no, everything in the while loop is ignored. It's done, and we just print the minimum. Did we find the smallest value out of this set of values? Yes, we did. And that is all. That's all there. So with those techniques, finding the minimum, maximum, counting and totals, you now could do so many different things when it comes to solving a problem, because now you have the tools to make decisions or to make a computer solve a problem in a way that it probably wouldn't have been able to solve it before with just a sequential program. So you have sequential selection and loops at your disposal, and you have some cool techniques to be able to swap variables, because all you're doing is manipulating the computer, and then you'll be able to work out some hard questions. Those hard questions I'll work out next week, because I'm tired.
This video is brought to you by makeITsimpleTT. Every class is structured to run on a yearly cycle from June to May. This cycle covers the whole syllabus in 12 months with 1 2-hour session per week, along with assignments that are given weekly. Every class is recorded so students can always go over the work and recap notes in case they miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799.